Now we'll look at hyperboloids. So this is the kind of thing that you get when all the squared terms are present, but one of them has a different sign from the others. So you have two positives and negatives, or two negatives and a positive, or something like that. Then we're going to be looking at level sets of a function that looks like this guy. And I've just chosen to have z be the one that's negative for purposes of illustration, but you could have the negative sign in front of either of the other two terms as well. So let's see. So if we put a equals b equals c equals 1 to simplify once again, and we look at the level surface where f is equal to 1, so where does it take the value 1, then we're going to be looking at the equation x squared plus y squared minus z squared is equal to 1. All right, so let's figure out what this guy looks like by doing some traces. So if we do z equals 0, and by the way, it's typically easiest when you're looking at things like this, look at traces for the odd man out. And since you can always divide through by minus sign to ensure that you have two positive terms and one negative term, what I mean is look for the negative guy. So that 0 right here is telling me I'll have a nice time plotting this one if I plot that variable z at different values. So let's see, for z equals 0, x squared plus y squared equals 1. So that's going to be the unit circle. And then if we go to z equals 1, x squared plus y squared equals 2. So I'll take that 1 and stick it over on the other side. And so if I go upstairs, then I'm going to have something. Now I've got a circle with radius square root of 2, so slightly bigger, and we'll call it that one. But now notice that z appears in this equation with a square. So that means that what I get by looking at minus 1 is going to be exactly the same. So that means that I have the same figure down below at minus 1. Okay, and maybe I should just a hair higher. Okay. And then we can look at what's going on in further up and further down as well. So let's see, so if I go up to 2 and down to minus 2, then we figure out what's going on in those slices by x squared plus y squared. And so then I've got a 4 that I shift to the other side, and shifting the 4 to the other side gives me 5. So what's the square root of 5? I don't know, but it's bigger than 2. So I'll just draw it like that. All right. And once we start to stitch this all together, we see that we have some thing that looks like this. Man, this is something that's really much better on a chalkboard. On a chalkboard, I can make these pictures look kind of pretty. On my little iPad here, it's not doing so hot. Okay. Anyway, yeah. So that's my first hyperboloid for you. Hyperboloid of one sheet. And so you can notice that each of these horizontal traces, that each trace is an ellipse. In this case, they're actually circles because I've taken both the coefficients to be the same, but in general, they'll be ellipses. And then actually these purple lines that I was drawing on there, those are actually hyperbolas. And so, for instance, like this one here that you get from looking just at the sides right there, that's going to be a, what is that? That's where I set x equal to 0, right? So that's y squared minus z squared equals 1. And all the other purple ones are going to be rotations of that one around the axis.